Welcome to the DIY Honda Garage channel. The DTC P1009 indicates a VTC, Variable Timing Control, Advanced Malfunction in the Honda Civic models from 2006 to 2011. This error signifies a problem with the mechanism that optimizes the timing of the engine's intake and exhaust valves. Proper timing is critical, as it ensures efficient engine performance, optimal fuel economy, and reduced emissions. The malfunction could stem from several components involved in the VTC system, including the VTC actuator, the oil control solenoid valve, or potential blockages in the oil passages. When the engine is running, the VTC actuator is responsible for adjusting the camshaft's position based on the oil pressure, which is controlled by the solenoid valve. Given the importance of these components, it is essential to troubleshoot this error methodically to restore full engine function. The VTC system in the Honda Civic is crucial for achieving optimal engine performance by adjusting the timing of the camshaft. The main components involved include the VTC actuator, which adjusts the camshaft position, and the VTC oil control solenoid valve, which regulates the oil flow to the actuator. The VTC strainer is also part of this system and is located in the oil passage. It filters the engine oil before it reaches the actuator. If the strainer becomes clogged, it can prevent adequate oil flow, resulting in a malfunction. Understanding the roles of these components is essential for diagnosing DTC P1009 effectively. These components are commonly housed near the engine's cylinder head and require specific access methods for proper inspection and potential replacement. There are several possible causes for DTC P1009. A clogged VTC strainer can obstruct oil flow, leading to inadequate performance of the VTC mechanism. If the oil control solenoid valve is faulty, it may not properly manage the oil pressure, which directly impacts the operation of the actuator. Another significant cause could be a malfunctioning VTC actuator itself, which may fail to adjust camshaft timing correctly. Identifying these issues is critical before proceeding, as resolving the malfunction typically requires inspection and sometimes replacement of these components. It is essential to understand that any of these failures could lead to erratic engine performance and increased emissions. Vehicles experiencing DTC P1009 may exhibit various symptoms, including rough idling, which can result from inefficient engine timing. Drivers might also notice reduced engine power during acceleration, leading to a less responsive driving experience. Additionally, the check engine light on the dashboard will illuminate, alerting the driver to the issue at hand. These symptoms derive from the engine's inability to optimally control valve timing, impacting overall performance. Beyond just driver comfort, these issues can affect fuel efficiency and emissions, making timely repair imperative. Hence, recognizing these symptoms early can lead to better outcomes. Begin the troubleshooting process by turning the ignition switch to the on position, which powers up the vehicle's electronics without starting the engine. Next, utilize the HDS, Honda Diagnostics system, to clear any stored DTCs. This step is essential to reset the system and eliminate false readings. After clearing the DTCs, proceed to start the engine and check for any pending or confirmed DTCs again using the HDS. If DTC P1009 appears again, it indicates a persisting issue requiring further investigation. If not, this may suggest an intermittent fault within the VTC system, which can sometimes resolve itself without further action. Once DTC P1009 is confirmed, turn the ignition switch to lock, ensuring the electronic systems are powered down. The next step involves removing the auto tensioner, which is part of the engine's timing chain system, to access the VTC strainer more easily. After the auto tensioner is removed, proceed to take out the VTC strainer located in the oil passage. This strainer filters the engine oil before it reaches the VTC actuator, and its condition can greatly influence the system's performance. It is crucial to handle these components carefully to avoid any damage, keeping in mind how critical they are to engine operation within the context of VTC functionality. The next critical step is to examine the VTC strainer for any signs of clogging or contamination. A clogged strainer can restrict oil flow, impeding the performance of the VTC system. If the strainer is found to be clogged, it must be cleaned thoroughly to restore proper oil flow. After cleaning, it is recommended to also replace the engine oil filter and change the engine oil to ensure the system operates smoothly. If the strainer is found in good condition, we can move forward with testing the VTC oil control solenoid valve. Understanding the condition of the strainer is vital as it directly correlates with the efficiency of the VTC system in regulating valve timing. After ensuring the VTC strainer is clean, the next step is to test the VTC oil control solenoid valve. This valve is integral in directing oil pressure to the VTC actuator, thus controlling the timing of the camshaft. If the solenoid operates correctly, we can confidently move on to inspecting the VTC actuator. However, if the solenoid fails the test, it will need to be replaced as it directly impacts the system's ability to function. Proper testing of this component is essential, as its malfunction could be the root cause of the DTC P1009 error. Understanding the solenoid's function emphasizes the importance of this testing step. The next action involves inspecting the VTC actuator to ensure it is functioning as intended. The actuator adjusts the camshaft's position based on the oil pressure from the solenoid, making it pivotal in regulating valve timing. If the actuator is found to be defective in its operation, it will require replacement to resolve the DTC P1009 error. Conversely, if it seems to be functioning properly, the technician should then check the entire VTC system's oil passages for blockages that could disrupt oil flow. This inspection should be thorough, as blocked passages can lead to recurring issues even after component replacements. Ensuring all parts are in working order is essential for comprehensive repairs. With potential issues resolved, turn the ignition switch to the on position again to reinitialize systems. Utilize the HDS to reset the ECM, engine control module, clearing any previous error codes from memory. Following this reset, it's essential to perform the ECM idle learn procedure, allowing the ECM to adapt to new parameters for optimal performance. This procedure ensures that the vehicle's idle timing is properly calibrated, which can significantly impact engine smoothness. After completing the idle learn, proceed with the CKP, crankshaft position, pattern clear, and CKP pattern learn procedure, which is crucial for the accurate detection of the crankshaft position by the ECM. This comprehensive process ensures that all adjustments are recognized and implemented effectively. In this final step, utilize the HDS once again to check for any pending or confirmed DTCs, including DTC P1009. If the code reappears, it suggests that the previous interventions did not resolve the issue. At this stage, it becomes critical to assess the oil passages at the VTC system for any blockages or restrictions preventing proper oil flow. An unimpeded flow is necessary for the VTC actuator to function effectively. Understanding that recurring issues may reveal underlying problems is key. Hence, a thorough inspection at this point is vital. Successful troubleshooting relies on the continuous monitoring of the system to ensure long-term resolution of the error. Once troubleshooting is completed, it's vital to conduct a final verification of the repairs. This involves double-checking the entire VTC system to ensure that all components are optimally functioning. All replaced parts should be carefully evaluated to confirm that they are installed correctly and are in good condition. Additionally, checking for lingering faults is essential, as it ensures that DTC P1009 has been properly resolved and does not resurface. It's also a good opportunity to conduct a test drive to observe real-world performance under various conditions. Successful resolution should reflect in seamless engine operation, indicating that the repair process has been effective. To prevent recurrence of DTC P1009, implementing a regular maintenance schedule is crucial. Frequent oil changes with high-quality oil ensure that debris does not accumulate, significantly reducing the risk of clogged components like the VTC strainer. Regularly checking the functionality of the VTC system components, such as the solenoid and actuator, can preemptively identify potential issues. Routine inspections of the engine will help spot problems before they escalate into serious repairs. Scheduling maintenance checks with a qualified technician is an effective way to promote vehicle longevity and performance. The importance of maintenance cannot be overstated, as proactive care minimizes the risk of future DTC occurrences. In summary, troubleshooting DTC P1009 requires a comprehensive approach to ensure that the VTC system is thoroughly examined and restored to optimal operation. Key components involved include the VTC oil control solenoid valve and the VTC actuator, both crucial for proper valve timing. Identifying and resolving issues through detailed steps promotes effective repairs and minimizes downtime. Furthermore, implementing regular maintenance practices, such as timely oil changes and routine inspections, significantly helps in preventing the recurrence of problems associated with the VTC system. Ensuring the components are in good working order can keep the engine performing efficiently while reducing emissions. Ultimately, an engaged approach to maintenance and repair leads to improved vehicle reliability. Please like and subscribe to the channel. See you next time!